How are you guys? Lopa, what are you doing in school, ma? What are you doing in school, ma? Lopa,
Yeah.
what are you doing in school?
We just took a test about transformations and like the calculator, like stuff that you told us about last class. We did a test on that yesterday.
Is it easy? Did you were you able
Mm,
to do some of the things that we discussed?
Yeah, it was like a really simple test. Like everyone got a good score on it.
Oh, nice. Okay.
But we're learning a new unit tomorrow, like next class. But yeah.
No, what is the unit?
I think I'm not really sure yet. I just know they're introducing something new. I can check on the lesson plan.
Would be nice. What are you doing, Parvini? You can as well tell me, Parvini.
We had a formative today on 2.1 to 2.6, like the residuals and the graphs, like,
Okay.
and we're starting 2.7 today. We started it today.
Okay. How about Shragbi? What are you discussing in Dhwani? What are you discussing in school, ma?
We started or we're reviewing exponential functions, and we also learned a little about unit circle.
We just finished 2.4, which was like manipulating the exponents using like the three properties.
Come again, Madhvani?
We finished 2.4 where we did like the manipulation of the exponents where like you use the three properties of exponents and like you kind of put it into exponential form like to give you form like that.
Oh, I see.
And can I leave 5 minutes early just because like I have a meeting at 9 just for today?
Sure, no. Let's go ahead. Advik, when is pre-calculus starting for you at school?
January.
January. Okay. Okay, so before that, we have to complete logarithmic functions and enter into polar functions as well. Let's see. Okay. And oh my gosh.
Miss Priya,
Yeah, ma?
can you like touch on like the decomposition of a function?
Going to do, ma, today.
Okay.
Tell you the plan first of all. Number one, we're going to do competing function model validation. Meaning, when we have different types of functions, which function fits for what, that's something we'll do. Okay. Second thing, what we want to do is this is related to composition of functions. Okay. Domain range. Akash had asked how to find the domain of composite functions. All that will come in. This is split into two. And then finally, we'll finish up with inverse functions. Okay, this is a longer unit. Okay, so these three are what is planned for today. After completing these, I'll move on to logarithmic functions from next week. Make sense? So the composition of function is what you are asking, remember? And then here finding the domain and range was what was difficult, right? That's what once Akash had asked as well. So we will cover that in detail. Competing function model validation is pretty simple, that is related to error and residuals. So let's quickly go over the residual functions and residuals ones. Okay. So now I really wanted to go to, let me switch this off. Oh, that's better. Okay. So how do you find out whether it's a quadratic function or an exponential function or a linear model? If you're given a function, right, how do you find out linear, exponential, quadratic that you know? Usually, you don't have to go for r and r square, okay? But what you can do based on the given data, you can put it in the calculator, see the graph literally. That's the best way to get going with this, okay? Or there is one more way, contextual clues, meaning based on the context that's given, right? Or based on whatever you have learned earlier, oh, this can be a linear model or this can be an exponential model. Context clues is the first help I would get is from contextual clues. From the given word problem itself, am I able to identify what type of function it is? Otherwise, plot it into the graph and go ahead and find out. The main other way is using residual plots. What is this residual plots? Okay. Now, let's say there is an exponential function. There is an exponential function. I'll show you a graph, okay? Let's say I have this exponential graph. In this exponential graph, when you look at it, right, these are the actual values. The dotted values are the actual values, okay? This one comes up from our predictions. I'll show you what is our prediction as well. When you look at this point in the graph, right, the actual value is less than the predicted value. Am I making sense, guys? When you consider this point, right, the predicted value is less than the actual value. This one you see, predicted value is more than the vertically you see. What is the difference vertically between the actual and the predicted? This is the difference between the actual and predicted when you think about it for this graph. So here it is positive. What I am doing, I'm trying to calculate actual minus predicted. So when I calculate this actual minus predicted, right, here it is positive, right? Here it is negative. Here it is positive. Here it is negative, positive, negative, positive. Any questions here? Any questions still here? Akash, what are you doing in school, Akash and Manav?
We just had a test on rational functions. I think we're doing exponential next.
Oh, you're going slow then. So that should be good, right?
Yeah.
Oh, that's good. That's good to know. Okay. When you think about an exponential function, so we are trying to calculate the actual minus the predicted value here, right? So what is a residual? Residual is the measure of how much a curve vertically misses a data point. Now let's consider this actual minus predicted in this case. Let's say this is called the residual. Residual is, as I said here, right? Actual minus predict. Guys, it's quite important. Don't change the order, guys. Do not change the order. Residual is the actual thing, actual graph minus the predicted value. Okay. We end up, see, from here, once you find the residual, you can plot a residual graph. What is that residual graph? You can plot, let's say, you will think that the x-axis is your actual value. Thinking that x-axis is your actual value, you can go ahead and draw the graph of residuals. So how will that look like? Let's say, for this function itself, right? Let me try this one. The residual plot would look like something here. Here, when you look at it, right? Uh, Here, if I consider this as positive, let's say 15. What is this? This one is very small, right? Maybe 5 minus 5. Like that, I find the residual between the actual minus the predicted values. Here as well, when you think about it, this is 100 to 120. So there's a positive 20. When you think about it, these are so small, right? This is plus 5. There is a minus, this one is say minus maybe 2. Here it's a positive 5 maybe. So like that, if you give some values for the difference between actual minus predicted, you can come up with a residual graph. Let's find out a residual graph for this itself. So this is our exponential graph. When you think about it, see, I drew something. So here, my drawing has also come. So when you think about it, this part is this. So thinking about it, this is your actual graph. Let's say if this is your actual graph, see, the first is a positive value of the residual. Then there is a negative value of the residual. Then there is a positive value of 5, right? This one I'm taking it as a 3, minus 3. This one I'm taking it as plus 4. So similarly, again there is a negative value, you see. Now a positive, negative, positive, positive, negative, positive. This vertical distance is called the residual. Any questions still here?
Miss Priya,
Yeah, ma?
is it always going to be in the same pattern?
No. Residual can be anything. It just depends. We don't know. We are just taking a sample graph where the actual is here and our predicted values. I am just giving my own predicted values. You see, the predicted values can be anywhere. See, another time for a exponential graph, your predicted values can be like this as well. You see what I mean? Then it is always negative. You see what I mean?
Yeah.
So just an example I took. It can be negative, it can be positive. But one thing remember, in a residual plot, the more the points are tangled everywhere, this should not follow a pattern. It has to be everywhere, all around the place. Then it is a good plot. Meaning it's a good plot means the model fits better. If this residual plot forms a pattern, let's say it forms a pattern like this, a line. Let's take these off. Let's say this residual model forms a pattern like proper line, or it can sometimes be like this, a parabola, or it can even be a parabola. Or whenever you see a proper line, right, the residual following a proper pattern, right, then the model does not properly fit whatever we are discussing. That you need to know. So the more they are everywhere, the residuals are everywhere, positive, negative, positive, negative, positive, negative, however it is, right? Then the model is a better fit for the data given. We'll come across that. Now we did understand what was residual, actual minus the predicted value. Now one more important thing. From here we said residual was actual minus predicted. Okay. Now the error is just the opposite. Error is predicted minus actual. Make sense? Error will have the opposite sign of the residual. Any questions here? There are two different definitions that we are coming up with. One is the residual, which is the actual minus predicted. The thing is, the residual will be negative. Residual will be negative when the actual is lesser than the predicted. So basically residual and negative, sometimes people say, hey, you can take residual instead of the error or error instead of the residual. Both are one and the same. I agree. But then the sign, there is a difference. And because of the sign, you look at the sign of the error that tells you whether our model, our real model is an overestimate or underestimate based on overestimate or an underestimate of the reality. That tells. Okay, so to find out, we need to be able to find the error every time. The sign of the error can clearly tell you if it is an overestimate or an underestimate. Make sense? Okay, now let's do one problem, then you'll really understand what's going on as well, rather than abstract this way of explaining things. What is going on? Okay, how about this? Can we do this one? You are going to do it in the calculator, guys. You are going to tell me, please. Okay, I'm going to give you a table. This is the table. So first let me know. You can draw a linear regression curve for this. You can do a linear regression curve. First find out the linear regression for this. So tell me what is the equation? What is the equation of the function?
To what decimal do we round to?
What decimal do you round to? For me, anything is okay.
Wait,
as
which
long as-
residual? Are we finding the residual of every single one?
I'm not asking you to find the residual. I'm asking you to plot a linear regression for this
Oh,
and
okay,
give
okay.
me the equation of f of x. Let's say this is f of t or m of t. See, output is m of t. Can you write the equation for this? Who joined now? Somebody joined now. Sorry, I just lost track. Who joined now?
Shri.
Okay, okay, sure. I would like to cover inverses as well as composition today, guys. See, once we are able to complete those 4 units, right, then we can work on some sort of I can get you 5 mock practice tests for the AP exam, 4 or 5 mock practice tests for the AP exam. The sooner we complete, it'll be good. Let's see. Did you get the equation? Okay. If you get the equation, I want one another question from you. What is m of 50? Both answers, please give. What is, first find out the equation, then find out what is m of 50. This is question A, question B. Now we'll calculate the error.
Wait, what point do we calculate the error of?
For 50 itself, because 50 is given, right? That's why I gave you 50.
Oh,
Real is given, predicted is from your equation, right?
yeah, yeah.
We are doing a linear model. So we'll calculate the error. The sign of the error tells you whether it is an underestimate or overestimate. At that point, let's say. It's an easy one, but
Wait,
just
Miss
that you should
Priya,
not get
I
confused, that's all.
don't understand
What
what
is,
we're supposed to do for A.
sorry, what was that?
Like, wait, what's the question for A? Like, I understand B and C, but
Yeah, we are just finding the linear
like, I don't
regression
understand
model,
what.
that's all. You type this
And
into your calculator, find the linear regression
oh,
model.
okay.
Yes,
Okay.
Sahil, that's right, Sahil. Sahil, how's your brother doing?
Oh, good.
Good, okay. 50. Yep, that's right. Advik, both are right, Advik. Oh, yeah, that's right, Sahil. Parvini, yep. So if the error is negative, the model is an underestimate. If the error is positive, see, error is basically predicted minus actual, right? So if the error is negative, it is an underestimate. If the error is positive, it's an overestimate, that's all. Dhwani, is that the answer for number 2? Number 2 doesn't seem right, Dhwani. Did you round it too much?
For
Yeah,
MF50?
the model is incorrect, ma. The model numbers are incorrect.
Okay, let me
Okay,
check
I
my
can go. Yeah.
points.
Let me write it down. So this should be Lopa. I didn't get an answer. Shri, I didn't get an answer as well. So what is M of 50? Predicted should be done from the equation. Predicted should be done. Oh yeah, Lopa. Nice to see your answer, Lopa. I really like that. But predicted should be from your equation. How did you get the 12? Oh yeah, yeah. Advik, it's not 20. 20 is the real. M of 50, I'm asking you for the predicted value. This is
okay.
the actual.
Mm-hmm.
So M of 50 actual is 20. I'm asking you for the predicted value. Once you get it, you can find out the error. Yeah. Sushank, you have to be very, very careful with the sign of the error. Akash, did you get it, Akash?
I'm almost done.
Guys, videos are mandatory, guys. I'm sorry to advocate on that, okay? But yeah. It's an online class. I really
Miss Priya,
want
can
to
you
do.
check my equation now?
Sure, ma. 417, that's all, Dhwani.
Hmm?
416 you got, huh? Okay, correct, Dhwani.
Yeah, and I'm sending you the rest
See,
too.
you're not rounding it properly. I feel still 0.417 should be there.
Oh, in school they taught us you can just cut it off. You don't have to round. I'll round it next time.
Yeah, you can cut it off, but
I'll
then the
round.
value will slightly differ, right, ma?
Yeah,
But
I'll
your
round.
value seems incorrect too. M of t should be somewhere around 12.1, 12.15.
I have a question.
Go ahead.
You said my sign was wrong. I thought the error should be negative, right?
Yeah, but your error was positive, right, Sushank?
I think I put my error as negative.
No, right, Sushank? See?
Wait,
Now
what did you want us to round it to?
anything is okay, ma. As long as the whatever decimals you given to me are right. Usually do it till 3 decimals for sure in these problems. Yeah, Sushank, now you changed it. See? Minus
Yeah, I
7.
realized I didn't put the sign.
No problem. So since the error is negative, this value the at that 50th value, it is an underestimate. Make sense?
Miss Priya.
Yeah, ma?
So if like there's a word problem or like a problem like this, it would ask for like error or residual.
Mm.
Okay.
Oh, la, la. I didn't get your question. I'm sorry. What is it?
Like would it ask for like error, like what is the error or like what is the residual?
They won't ask like that, right? They will ask you, hey, write the equation for the regression model, find out a value, meaning function value at some point, tell me whether it is an underestimate or an overestimate, they'll ask. In that case, you need to find out the error at that point and see if it is negative or positive. And if it is negative, it's an underestimate. Positive means overestimate.
No, because at school, on the tests and stuff, it's like find the residual value and
Then it's very easy, right, Parvini? If they
yeah.
directly ask you what is the residual value, it's easy, right? Actual minus predicted.
Mm.
Does
But
it make
like,
sense?
but we did predicted minus actual, right?
Amma, there are two things. One is residual, one is error.
Are they completely different things?
What is it, ma?
Are they completely different things?
They are exactly the same. One is, but there is one difference between the two. Residual is actual minus predicted. Error is predicted minus actual. Why I am particular about the sign is, sign of the error only tells you whether it is an underestimate or overestimate. Or in another way, I can say opposite sign of the residual tells whether it is an underestimate or an overestimate. The magnitude, the value that you get for both will exactly be the same, but the sign will be different. Sign of the error, if it is negative, then it is an underestimate. Positive means it's an overestimate. Or you can say the residual is negative, it's an overestimate. Residual is positive, it's an underestimate. That is also fine. Got it?
Okay.
You can find alternatively, but you have to know when to say underestimate and overestimate. Because that's why to avoid confusion, I'm saying find out the error. Make sense?
Yeah.
Okay, now let's go ahead and give this. The predicted. Okay, so now this one is a good one. This one is coming to confuse you. I really want you to try identifying. Each of you give me the answer in chat. Let me check if you understood. Several cars were tested for their braking distance. Regression model was calculated with the car's weight as input values and braking distance as output values. Okay, so car weight is 3,300. Okay, at some point P, this is the point P. Point P is also given. Do you see? This model is 3,300 minus 15. This is a plot of what? Residuals. Tell me, what does point P indicate in this context? Basically, what they're asking is it an underestimate or an overestimate? But you need to be careful, a little more careful here. Guys, I'll wait for your answer. I did explain, but I don't know whether you all took it in.
Miss Priya,
Uh-huh.
is that line the x-axis or?
X-axis is always, think that dark line is always the actual.
Okay.
Okay. The points will tell the residuals.
Okay.
That's right, Shri. Dhwani, I'm waiting for your answer. Manav, did you already answer?
Yeah.
Okay, Manav.
Is it correct?
Yes, I think so. Was it 1 minute? Let me see. The serial is given. Yeah, that's right.
Miss Priya submitted my answer.
Yes, yes, Mastery, that is correct. Nice of you.
Thank you.
And for you to remember, I'll also tell one more thing about these residual plots. Guys, I'm waiting for your answers. Guys, please send it. If you don't know, say you don't know. Yes, Dhwani, that is correct. When the car weight is 3,300, the predicted value is not minus 15, Dhwani.
Yeah, that's what I was about to say. I did it wrong. I was
Yeah,
really
it's not the predicted value. The difference between
yeah,
actual
it's
and
the
predicted
error.
is 50 minus 15. So, what can you tell whether it is an underestimate or an overestimate?
It's this is like
Uh,
it's actual minus predicted, right?
yeah, residual is actual minus
It's
predicted. That's why I'm saying never confuse. The sign of the error is only correct. Based on that, you can say underestimate or overestimate.
so this one's overestimated.
Correct. Good job. Sushank, do you realize what mistake you did, Sushank?
Yeah.
See, one way to remember a raw way, sign of the error tells you. Here they have given you only residual. So the opposite sign of the residual is going to tell you whether it is an overestimate or an underestimate. So here, when you think about it, the residual is negative at that point, meaning the error is positive. So it is an overestimate. Make sense? Okay. Now, for you all to remember, I just want you to remember this. Lopa, did you understand?
Yeah, I did. We haven't done visual plots like this before. We only have done it on a table. So
Table, okay. See, these are tricky questions. That's all. Hey, Parvini, did you understand, ma? Looks like you did not.
I'm a little confused, but like,
What are you confused on there?
the graph is a little confusing. I didn't really understand the graph part.
Don't worry at all. See, this is the residual graph, okay? This is our plot value, actual value, okay? If the error is up there, the residual is positive. If a point down is there, the residual is negative. That's all. You get it?
Okay.
Now, error is the opposite sign of the residual. You got it? So, error in this case is positive. Error in this case is negative. Did you get it?
Yeah.
Now, this was the point. So, error has a positive value. So, it's an overestimate. Make sense?
Yeah. Thank you.
How about, see, if you have residual plots like this, right? I said all across, positive, negative, positive, negative. See, this cancels with this cancels with this cancels with this. So like that, if the residuals are able to cancel with each other and the pattern is everywhere, there's no proper pattern, then it is a good model that depicts the regression curve, meaning the predicted values are good values, meaning predicted values resemble the actual values and it is a good fit. Regression model is a good fit. Whereas in this case, when you look at it, right, they clearly form a pattern. The right side is forming a line, the left side is forming a parabola. These are really bad residual models. Make sense? Okay, so that you need to remember, that's all. Now let's see. Let's go to move on to composition of functions. Guys, this one most of you have done earlier, but I don't know how many of you remember. When it comes to composition of functions, right? Let me do one problem and after that I'll ask you to do. Okay, so basically let me first explain. I think you all know though. So let's say if I give you f of x equal to x square plus 1, g of x equal to, let's say, x plus 1. If I give you this, right? Uh, Composition of function means composing function one into the other. That means what? Now, if I ask you, this is a composite function. What do I do? Instead of the x, right? Instead of my input for f, right? I am plugging in g of x. Do you get it? I am passing, this is my function. The outer function is my original function. I am passing one another function as the input to my outer function. You see, wherever I see x. So f of, this is read as f of g of x. This is written as, you are going to plug in g of x into wherever you see x. So f of, I'm going to plug in x plus 1, right, equal to x plus 1 the whole square plus 1. So x square plus 1 plus 2x plus 1, right? So you get x square plus 2x plus 2. This is your composed function. Any questions? Any questions? சாப்பிட, yeah. Yes. Okay. Now the next one is g of f of x. Let's consider the same function is equal to x square plus 1. G of x equal to x plus 1. Now, g of f of x means what? G of x is my original function. I'm going to plug in my f of x. I'm going to plug in this function. I'm going to feed that function as the input to the other function. So, g of f of x. So, wherever I see x, right, I'm going to plug in x square plus 1 plus 1. Make sense, guys? So, this will be x square plus 2. Any questions here? This came from algebra 2, so you should all be clear, I feel. Advik, are you clear?
Yeah.
Okay, now guys, can you find these two? First of all, find g of 5. First of all, find the innermost function. First, you find g of 5. Then plug that g of 5. Whatever you get for g of 5 should be fed as input to f of x function. Find both. That is correct, Advik. Shagvi, nice to see your answer. Oh, correct, Parvini. Sushank, correct. So all of you are good with this. Nice. Dhwani, correct. Yes, please go, Shagvi. Sahil, correct. Okay, guys. Shri, I didn't get the answer. Akash, I didn't get it. Did you understand?
Yeah, I'm solving. I'm solving.
Yeah, I got you.
Okay. The main thing about this is the concept behind this is given a table, given a graph, given, what did I give you now? An equation. Given an equation, given a table, given a graph. You should be able to do composition of functions very well. Okay. So we will work on only one sample of each. Okay, let's see. We did what did we do? We did equations, right? Shri, are you sending?
Oh, yeah.
Okay, go ahead. I'll wait for you. Siddhi, nice to get your answer, but did you understand the previous one on error and residual? Siddhi, I didn't get your answers, right, Siddhi?
Yeah, I understood.
Okay, Akash, only one I got. Does it mean that you understood? Ah, Lopa, is it minus 18 or minus 19, ma?
Oh, sorry, I made a mistake. Sorry about that.
No problem. There's no problem in making this, but did you understand? You should have gotten minus 18, that's all. Okay, Shri, I
I
didn't get
sent
it.
both.
Yes, I saw. Thank you, Akash. Use the table to find out the values of the composed functions below.
Miss
Can we
Priya,
try?
send my answers.
Yes, Shri, thank you. So this is a table. Next one, you'll get a graph. You can send all the three together. I think you're all getting it well. Siddhi, that's right, Siddhi. I should check answers. Are you getting this? Ah, yes. There are 6 answers. Second one is incorrect, Akash. You guys, you're confusing me. 1 and 2 are incorrect, Dhwani.
Which one is?
1 and 2 are incorrect, Dhwani. Sushank, 2 and 3 are incorrect. Manav, all are correct. Parvini, the third one is incorrect. Ma, you need to be careful.
I was gonna ask a question about the second and third one. When
I'll
it just
definitely
says,
go ahead. Sorry, Sushank. Sorry,
when
Sushank.
it just says F or just says G, what do I put for that? Like, do I just say 0?
See, that's what I wanted to say. So this notation says you read it as f of g of minus 2. So you can write it out as this one, Sushank. Here, this is g of f of 2. So you can,
Oh, okay. I thought it was just like, oh, okay, okay.
sorry, I should have told you about notations too. And the next thing I was about to say, but I did not look at it here that you had notation. I'm sorry. Sahil, that's right. Parvini, that's right, ma. Shall I do it for anybody? Lopa, did you get it? Shragvi, are you back, Amma?
Yeah, I'm doing it.
Okay, I'm going to wait. Shri, where am I? Where are you? You're just putting it at your ceiling. That doesn't give you accountability at all. I'm sorry to ask.
Is my answer correct? I changed it.
Oh, Miss Priya, I went to the restroom. I forgot to type a message. Sorry.
Oh, okay. No problem. No. If you see, that's why I'm saying if you're on the video fully, then I'll understand whether you're there or not.
Okay, yeah, my bad.
Sushank, what was that? I'm sorry. What did you ask?
Is my answer correct? I edited it.
Yes. I feel like I saw. Let's see. Sushank. Yes, everything is right. Dhwani, did you get it, ma? Yes, Shagvi, good job.
Yeah, when I was looking at the final answer, I accidentally always looked at GFX.
Oh, okay. So it went wrong. Okay. The last one will be one graph. Okay. Since you've done this, we don't need to work on this a lot, I felt. Given this graph, right, I'll give you a graph. Just tell me f of g of 1, g of f of minus 2. Give you a graph. Okay, this is the graph. Just get me f of g of 1. F of g of 1. Second question is, just get me g of f of minus 2. I think that's enough, right? Why to do more? And g of f of 1 maybe. Those three. Then I'm going to ask you a question. Let's see whether I get the answer for that.
Are my answers correct?
I submitted my answers, Miss Priya.
Sorry, I did not see the
And I have
chat.
to go too after this.
Yeah, I know. Okay, bye. You go. But anyway, he's also coming late.
Wait, are my answers right?
Yeah, I'm checking. 1 minute, Akash. I'm checking. Yes, Akash. You
Okay,
can leave.
bye.
We'll finish inverses. That's all. Yeah,
Okay.
that is correct.
Miss Priya, are my answers correct?
Dhwani, the third one is it right, ma? I'll check Dhwani. I feel like the third one was incorrect, Dhwani. I
Oh,
don't know.
sorry, I forgot to put the negative sign.
Yeah. Manav, the third one is incorrect, Manav.
Miss
Shri
Priya,
correct.
is my answer correct? Okay.
Thank you.
Sahil, the third one is incorrect, ma. Why the third one is hard, huh? Innama. Yep, that's right. Can I move on? -1 for the last answer. Any questions? Lopa, did you have any question on that? Can I explain? Parvini, I did not get your answer right, ma.
Miss Priya, I
You,
sent it to you.
yes, Lopa, you sent it. I'm so sorry, Lopa. Parvini, you sent, huh?
Yeah, I sent it when you.
Okay, if you send it, great. Yes, everything is correct. Can I move on? One second. So, guys, do you know what is the additive identity? What is the multiplicative identity? What do you mean by multiplicative identity and additive identity? Siddhi, I didn't get your answer. Where are you?
I sent it just now.
Just now. Okay. I did not see, honestly. 30 minus 1, Siddhi, the last answer.
Okay.
What is additive identity and what is multiplicative identity? It's just a revision of what we already learned earlier classes. What is multiplicative identity? What is additive identity? What is that in mathematics, guys? Hey, if you know, please tell. If you don't know as well,
Miss
please tell.
Priya, is it that thing with the exponents where like a of x?
Nothing hard. This is just based on elementary level. No. Additive identity. Let's say, you know what is additive identity? Let's say there is a number, okay? There is a number 1, there is a number 2. If you add 0, the identity of 2 remains. You see? If you have a number 3, if you add 0, the identity of 3 doesn't change. You see? So, the additive identity is always 0. Can you tell me what is a multiplicative identity then? In mathematics, what is a additive identity is 0. The identity of the number doesn't change with 0. So you call 0 as the additive identity. What is a multiplicative identity?
So like when it multiplies with 0, and like when anything multiplies with 0, what happens?
Correct. So what is
Or
no,
like
no. The identity of any number, let's say a number x, x plus 0 remains as x. The identity of x doesn't change with your
like, so
additive
like
identity.
so for like if it was for the
Oh, wait,
multiplication,
0
it'd
minus
be
x or whatever number.
Uh-huh.
like the
Mana,
multiplication one.
one. Mm.
Would it be like x times 0 equals 0 or something?
X times 0 becomes 0. So that's not the multiplicative identity, right?
Oh,
Is it
okay.
0 minus x? Because that's what the number like changes.
Where?
to.
I think I did not help you understand properly. Additive identity means.
No, that's for multiplicative identity.
Yeah, what is the multiplicative identity you're saying?
If number is like 5 times 0 equals 0, the identity is like 0 minus the
5
original
times
number.
0 is 0. Then see, whatever you multiply with should be your multiplicative identity. But the number you multiply with, right, that should not change the identity of your original number.
Is it times 1?
1 is your multiplicative identity. You got it? 1 does not change the value of the original number when multiplied. So 1 is your multiplicative identity, 0 is your additive identity. Can I move on?
Oh, it's what number that keeps your number the same.
Yes, the identity of the number remains the same. Got it?
Yeah.
Okay. Let's say there is a function f of x equal to x. F of x equal to x. What is f of g of x? What is f of g of x? What is f of g of x?
F of g of x is g of x?
Yes, because see, whatever you've given as input comes out as output. Here, g of x is your input that comes out as output. Now, do you see the given input comes out as output? The identity is not changed here. Do you see when we discuss additive identity, x plus 0, this is your input. Okay, the output I generated was this. The input had the output was the identity of the x did not change. Y, any number y plus 0 remained as y in the output, right? When it came to multiplicative identity, x times 1 is equal to x, y times 1 equal to y. So what happened here? X was x, y was y, right? They did not change, they retained their identity, and this was called the multiplicative identity. This was called the additive identity. Now here, I considered a function f of x equal to x, right? Now with this function, if I have the function as x, right? Now, f of g of x is my input. It retained the output was also g of x. Now, h of x is the input, output will also be h of x. The identity of this function never changes, right? If f of x equal to x. So, what is the function identity? I told you about additive identity, multiplicative identity. What is function identity? Which of these is identity function?
F of x?
F of x. F of x equal to x. You got it?
Yeah.
F of x equal to x is your identity function. Make sense? Because if you use f of x equal to x, whatever input you give, it comes out as output. So the identity, the value of what you give comes out as output. The value doesn't change at all. That is why it's called the identity function. Can I move on? Can I move on?
Yeah.
How about this? Will you be able to do this, you think? I would like to finish inverses too. Let's see. That's what I planned for today. But we need to finish this at least by 50. 9:50 we are able to finish. Then we can finish that. And we can do some problems as well. Exam problems we can do. Let's see. F of x equal to x square minus 1. G of x equal to square root of x. Find the function h of x, which is f of g of x. Got it? Oh wow, that's good. Manav, that's right, Manav.
Miss Priya, I don't.
Lopa, I'll help you, ma. Lopa, that's right though. What you didn't get?
Oh, oh no, I just like I don't think it doesn't look right, but
No, that is correct.
okay. Can you
No
just
need to-
explain it though? I
I
don't
will
know.
explain. Absolutely. Yes, please ask like that. I would be happy to. Okay. So, Siddhi, did you get it? Sahil, why you're not answering, Sahil? Sahil.
I put it in the chat.
You put it in the chat. Okay. F of x equal to x square minus 1. G of x equal to square root of x. Now we are composing function. What are we doing? We are giving g of x as the input to the f function. This is our original function. Instead of x, I'm going to plug in g of x. Instead of x, wherever I see x, I'm going to plug in g of x. I see x here. So I have to plug in root x instead of the x. But there is a square to it. Minus 1. F of g of x will be equal to root x square is x minus 1. Any questions? Okay, now let's see this one. Yeah, this one. 2x minus x square and x plus 1. 2x minus x square and x plus 1. 2x, this is a tricky one. X square and x plus 1. This is g of x. This is f of x. Shragbi, did you get it? I did not get responses from you, Ma, so I did not know whether you're understanding. You have to find f of g of x. You have to find f of g of x. What is the answer to this? Slightly tricky than what you did. Let me see whether you get it right. All of you. I said 2x minus x square and then x plus 1. Go ahead. Can I help or did you all get it? Is that right? I don't know. I don't think it's right, Advik. I told you this is slightly tricky, I told you. No, Dhwani. Parvini. No, Parvini.
Is my answer
Everybody did the same mistake. Manav, no, Manav.
is my answer correct?
Sushank, no, Sushank. Did I give it to you incorrectly? Wait. 2x minus x square I gave you. X plus 1 I gave correct. Sahil. No, Sahil.
Miss Priya, can you check my answer now?
X minus 1. No, Shragvi. No, Sahil. Dhwani, I can check your answer again. Not really, ma. Okay, can I do? Maybe I'm doing, meaning, I don't know where, meaning. It was a tad bit tricky. That's why I told you it's a tad bit tricky, but that was not so tricky. Let's see.
Does it
F
go to
of,
imaginary numbers?
or maybe, no. Maybe I gave it to you incorrectly. Let me check once, guys. Give me a minute. F of g of x, because nobody got it. Why? Let me see. F of g. Okay, let's do it on the board and see. Okay, so f of g of x. So this is my original function. F of x equal to 2x minus x squared. Now, wherever I see x, I'm going to plug in g of x, right? Instead of this one, right? 2 times g of x. 2 times x plus 1 minus, see that. This is what makes it tricky. Minus x square becomes x plus 1 the whole square. Here, 2x plus 2 is easy, no problem. But then, here what do? This is a plus b the whole square, right? And a minus is there. So, x square plus 2x plus 1. So, the minus has to be distributed. This is where everybody will make a mistake. They would love to give things like these. So, this gets cancelled, right? Then, it will be minus x square plus 1, right, ma? Nobody got it.
Miss
Am I
Priya,
not? Yeah, ma?
I think we all forgot to do the x plus 1 times x plus
Distribution, right? This one, right?
no, the x plus 1
Oh,
times x plus 1.
oh my God. Okay, you did not expand this, huh?
No.
Oh, good to know. Good to know. Don't forget it. Okay, I'm glad. Okay, Siddhi, did you understand, Siddhi?
Yeah.
Okay, Lopa, minus x square plus 1, amma.
Oh, sorry. I think I like
No,
wrote
this
it. I,
plus 2 and
I
minus
got.
1 becomes plus 1.
Yeah, I messed it up.
Okay, no worries. As long as you understand, it's good. Okay, now let's go ahead. There comes the harder piece. I really want to finish this well. Okay, coming to a domain of a composed function, a composition function, domain of a composed function, right? First of all, we are treating, let's consider this function, f of g of x. Okay, now g of x is a function, f of x is a function, right? Coming to that, you see, we are giving x as the input to g, right? So you need to consider the domain of g. Domain of the inner function you need to consider, because we need to consider the x values that come within the domain of G. Make sense? First thing. Second thing, the output of G of x. The output of G of x must be in the domain of f of x because you are feeding that as input. The domain of G of x must be in the domain of f of x. How to verify that? Verify the final function that you get. Okay. If you have any restrictions on the final function, you have to account for it. There are two things, guys. Given a function, this is quite important. This is what Akash asked and he's not in here. So now f of g of x, this is a function. Okay. Now this is a composed function. First of all, you're feeding x as the input to your g function. First thing, so what you need to consider is, you need to consider all x values in the domain of G. All x values in the domain of G you have to consider. Then we get the final function f of g of x, right? Here, whatever you feed in, the output values of g of x should be in the input values of f of x function. For you to verify that, how will you verify? Do one thing, see the final function. Okay, check if there are restrictions for this function. That you need to take into account. Restrictions on f of g of x you need to take into account. First thing is, you will verify the x values of g of x. X values of g of x you will verify. If there are restrictions, you will take into account. Second is, the final function you will see. There you see any restrictions, you have to account for it. Okay, why? Because x you are giving as the input to g of x. So all possible x values of the function g of x should be considered along with restrictions. Second thing is, you are feeding the function g of x to the f of x. As a result, you should make sure the output of g of x should be within the domain of f of x. How to verify that? You just consider the restrictions of the final function that we get. Let me explain with an example. This is so confusing when you think about it. I'm going to consider this function, the first function that we said. Okay, now let's see this one. It's a simple one. This I'll do, next one I'll do, next I'll make you do. This one is, let's say this one. Now, f of g of x. We need to find the domain. That's the question asked. Now, first of all, we need to see what? G of x. What did I say? All possible values. First is, you need to consider all x values of g of x with restrictions. This is quite important, okay? Second one is, find f of g of x, okay? And then see whether there are restrictions on that. These two steps you need to execute. Now you tell me, what are the x values possible for g of x? What is the restriction? Any restrictions there for this function? Do you have any restriction on the domain? Guys, you can all say, right? The function is square root of x. Okay, what are restrictions? If you have a function 1 by x, what is the restriction? Who can tell me? What will make the function undefined, guys? What will make the function undefined? That is a restriction. If you are given a function like this, what is the restriction on this function? At least you can say that you don't know, guys. This is so hard on me.
Would it be 0?
X can't be equal to 0. If x equal to 0, the entire function becomes undefined, right? X is not equal to 0 is an example of restriction. Okay. Suppose if I have a function square root of x. What is the restriction on that function? How can the value be of x be?
The x and y has to be greater than or equal
X
to 0.
alone has to be greater than or equal to 0, right?
Yeah.
Yeah, and here, yes, as you say, y as well is greater than or equal to 0, correct?
Yeah.
Great. So that is a restriction. Similarly, if I have 1 by x minus 2, what is the restriction on this function?
X not equal to.
X can't be equal to 2. Suppose you're given a rational function, 2x minus 1 by 2x plus 3. What is it, guys?
X cannot equal
X
negative
can't be
3
equal to what?
negative 3 over 2.
Miss,
Negative?
I'll
3
leave
over
now.
2.
I'll watch the video remaining.
Sure, ma. Sure, ma.
Thank you. Bye.
X can't be equal to minus 3 by 2. Then what?
Let's see. That's it.
Horizontal asymptote.
Shoot. Y cannot equal 1.
X can't be equal to 1. I'm sorry. Y can't be equal to 1. Correct. Horizontal asymptote, right?
Yeah.
Y can't be equal to 1. So these are restrictions that you can usually come across. Okay. Some examples I have given. Usually it is always based on these only. So let's see. That is what are restrictions. Okay. So when you think about it, right? See here. Let me give you an example. Y equal to x square. The graph is like this. But when I find the inverse, see inverse function, I did not discuss. Let me go there and discuss that. Let's first do this. Now here guys, here first of all, as a first step, I need to find out the restrictions on the x values of g of x. I'll look at g of x. What are my restrictions here? What are my restrictions on g of x?
X can't be equal to 0.
Uh, uh, x can't be equal to 0. No, whatever
X
is
cannot
inside.
be less than
Oh,
0.
X has to be greater than or equal to 0. Good. Now, let me find out f of g of x. What is f of g of x? F of g of x would be square root of x the whole square minus 1 x minus 1. Is there any restriction on this function? It's just a line. It goes on forever. Is there any restriction? None. Right? So, what is the domain of the composed function? Domain
X is greater
of
than or equal to
f
0.
of g of x is yes. Is what is that? Greater than or equal to 0. 0 comma infinite. Make sense, guys?
Yeah.
You have to consider this as well as if there are restrictions on this. Nothing in here, so you don't have to count. I'll do one more, as I said. This is a difficult part. So I'll do one more and then let you do one more. Okay, let's see this. I'll do this. Okay. But I want you to do one. I don't have it now. Let's see. I want you to do one. Let me get it. Okay. I'm going to do this for you. Siddhi, are you following Siddhi?
Yeah.
F of x is equal to square root of x minus 1. G of x equal to x square minus 8. Are there any restrictions on g of x? Are there any restrictions on g of x?
No. Just y has to be greater than equal to 8.
No, right? Meaning, see,
Or negative 8. Negative 8.
why on g of x? It's just, when you look at it, right, it's just a parabola graph. Pushed down by 8 points. That's all, right? There's no restriction, right? There is no undefined points at all on the graph, right?
Oh,
Wait,
it
Miss
just says
Priya,
never
Yeah.
goes to the bottom.
Miss Priya, is it literally just x squared minus a minus 1 and like square root of that?
Well, are you talking about f of g?
Yeah.
You're talking about
F of g, isn't it just like isn't it just like x squared minus 8 minus 1 and like the square root
I
of the whole
don't
thing?
know. I don't know. You're asking me too much in advance. But did you find out f of g in the domain? Let me finish explaining, right?
Okay, yeah, sure.
Yeah. So this is, does g of x have restrictions was my question. Shri, did you get that? G of x, does it have restrictions? Nothing in here because
No.
there is no undefined points in this graph. However, when you consider a square root function, it's only defined for x value greater than or equal to 0. So what can I do? This does not, the step 1 does not have any restriction. But now I have to find f of g of x. Then see what are the restrictions. For that, I'll substitute x square minus 1 minus 1. So that would be x square minus 2, right? Now, does this function have a restriction?
Wait,
Does
Miss
this
Priya,
function have an, yeah, ma, did I make a mistake? I think I made a mistake.
doesn't f of x have a restriction of like x can't?
1 second, ma, wait, ma,
I
I
think it's
did
supposed
it
to be x
incorrectly, ma.
squared minus 9.
Yeah, Maya, I did it incorrectly. This I need to substitute, right? X square minus 9. Instead of this x, I have to substitute x square minus 8 minus 1. So that becomes x square minus 9. Now, is there a restriction on this function?
Yeah.
Yes. What is the restriction?
Uh,
X square minus 9 is
it's negative. It has to be greater than.
or equal to 0. So x square is greater than or equal to 9. What does that mean? Take square root on both sides. X is greater than or equal to
3.
Plus or minus 3.
when you take square root, what should you do, guys?
No, it's negative 3 and x is greater than or equal to 3.
X is greater than or equal to
3.
plus or minus 3. X is greater than
If you
plus
plug
3.
in negative 2, it gets square root of negative 5.
Where, ma?
Because if you do greater than or equal to negative 3, then you'll get value negative square root.
No, right? X is greater than 3, first restriction. Second restriction is X is less than or equal to minus 3, right? You just change the
Oh,
sign.
I thought it was x is greater than or equal to both.
Yeah, X is greater than or equal to plus or minus 3. So you can split it out as X is greater than or equal to plus 3. X is greater than or equal to minus 3. When you, right?
Yeah.
Okay, so here the way you have to take it is, there will be a negative x greater than or equal to 3, you'll take it. Because when you take square root, right? Okay, let me show you better. Let me do it again. Let me show you better. So here when you take square roots, you add that because it doesn't make sense to say x is greater than or equal to plus or minus 3. So what you need to do here is, you can better say, see, when you take square root, plus or minus x is greater than or equal to 3. Okay, because when you say x is greater than 3, x is greater than minus 3, it's not making any sense. That's why I add the plus or minus in the x. So x is greater than or equal to 3. Minus x is greater than or equal to 3. But multiply by minus 1, this becomes x is less than or equal to minus 3. This makes sense. On a number line, when you think about this graph, right? This is minus 3, this is plus 3. So the part of the graph which is positive is above the x-axis. Make sense?
Yeah.
Okay.
Thank you.
So, did you get it? Why? So, now here the restrictions are minus infinity to minus 3, right? Minus infinity to minus 3. Minus 3 is included. And then what? Union 3 to infinity. Does that make sense, guys? No, if you didn't understand, you have to let me know, please.
Miss Priya,
Yeah, go ahead.
is there no restriction for f of x?
Let me see. No, you don't have. There is a restriction on f of x. But you don't need to account for it in f of g of x. You
Also,
see what I mean? Meaning you raise up a good question. Okay, what your question is, hey, this has a restriction. Is that not taken into account? No, because that's the outer function. You see what I mean? You have to only check whatever you provided as your input, g of x. Here, your input is g of x. So, all the x values on g of x is accounted. And then, finally, find the composed function. The restrictions on that composed function is taken into account. Whereas, you asked a good question. Suppose if I find out g of f of x, for the same thing, if I find out g of f of x, right? What happens? I have to take into account this restriction. X is greater than or equal to 1. Make sense?
yeah,
And I have to find out g of f of x. What is g of f of x? I will substitute x minus 1, the whole square minus 8. That becomes x minus 1 minus 8, x minus 9. There is no restriction on this function. So for this function, the domain restriction is x is greater than or equal to 1. Make sense?
So you only care about like the inside
Yes.
function.
Care about only the x values of the inside function.
Okay.
And then what do you care about? The final function's restrictions. Make sense, guys?
Yeah.
Mano, did you get that? This is a hard part.
Yeah, I get it.
How about you, Lopa? Siddhi?
Yeah, I
So this
understand.
one I can write the domain as, for this g of f of x, I can write the domain as 1 comma infinity. For f of g of x, I can write it down as this. Shall we solve more problems on this? I feel like it. This is quite important because basically in Algebra 2, we did not study this. This is a new thing. And you know, Akash asked about it 3-4 weeks back. Let me give you. Let me give you. I had some problems ready for you guys. This is 7. Okay, let's try this one. Oh, wow. Okay, let's see this one. 1 second, guys. I really want to give you something on this. 2, 7. Okay, let's try this one. How about this? You want to find out the domain and range of a composite function, right? This is a good one, but I don't know whether we can. Let's see. This is a good one. Let's see this one. Please think and then do. I'll give you time. Okay, these are test prep questions. Go ahead. See, the concepts is what we are discussing in class. But the problems, when it comes to assignments, you have to apply them. Sorry. G of 1 is, okay. They have given, see, what is given? F of G of 1. So start finding from G of 1. Then you can find F of G of 1. Okay. See, there are multiple unknowns. I'll wait, guys. If you're able to do it, great. If you're not able to, I'll do. Oh, wow. Good job, Sahil. But you have to find the domain, right? I have to give questions on domain. Let me see. I want something on domain. Domain of composed functions, right? Oh, wow. Lopa, good job. Mano, good job. Shragvi, nice. Okay, can I help anybody who needs help? Shri, what is the answer?
Yeah, I'm studying it right now.
So basically, what did you do? You started from here. So what is g of 1? We try to find out. G of 1 is what? Substitute x equal to 1 equal to 4b. Now, what we need to find? G of f of 1. That's what we need to find. We
Miss
know,
Priya submitted my answer.
yeah, we know g of 1 is 4b, but we can even use f of g of 1 is 36 is what is given, right? So g of 1 is 4b means f of 4b will be equal to 36. But if I give 4b as the input, right, This is 20b minus 2b will be equal to 36. 18b equal to 36, b equal to 2. Once I get that, g of f of 1 should be easy, right? So f of 1 is what? b you know is 4, right? So f of 1 is what? 5 minus 1 is 4. G of 5 minus 4 is 1. G of 1 is what? You plug that in. 4, 2, 1. So that is 8. Sushant, did you get it? Sushant, did you get it, Sushant?
Sorry, I was speaking on mute. Yeah, I got it.
Yeah, okay. Now let's go ahead with inverses. I do have some time, right? So let's please finish inverses. I want to finish inverses. That's the plan. Yeah, I know I did not give you more. Yeah, see, your decomposition as well, I didn't complete. Okay, how about this, guys? We need to be able to decompose a given function, meaning we always discuss composition, but how to decompose a function? If you're given h of x, right? If you're given h of x, right? Right, what is h of x is f of g of x, right? What is f of x and g of x? Who can tell me? Basically, whatever is inside the square root is my inner function. G of x is x cube plus 1. What is f of x? Square root of x. Make sense, guys? It's easy. It's just composition. So, whatever is inside this, one is square root function, one is a cubic function. Cubic function is your innermost function. Whatever is the outside function is your other function, outside function. Okay, let's find out this one. You're going to tell me, okay? You can, one of you can shout out. How about this? Are you able to find this?
Miss Priya, we can't see.
You can see? Should I
We
make
only
it
see
bigger?
the first problem.
Oh, you only see the first problem. Oh, I'm sorry. It was my bad. I failed. Let's see. Let me give you another difficult function I feel now.
Miss Priya, I have to go.
Yeah, you can now.
All right, bye, Miss Priya. Thank you.
How about this? Inverse function, even we can cover tomorrow. Let's see this one. H of x, how about this? How will you find out the two functions here? H of x equal to 1 by x square plus 1. You can shout out, guys. This is pretty easy, right? You can tell me. Right.
Would one of them be 1 by x?
Yeah, one has to be
1 by x?
1 by x. Is it so?
Or is it x?
Yeah, one has to be 1 by x. Yes, outer function has to be 1 by x. Correct. The other one is?
X squared plus 2. X squared plus 1. X squared.
Yeah, x square plus 1 is your innermost function. Right? And then the outer function is 1 by x. Make sense?
Mm.
Okay. I really want to do a few more. Hold on. I think I didn't get it. Okay. So, one thing, guys, do you want to discuss inverses next week or this week? I will leave it to you. You have been through so much. Let me know. Do you want to discuss inverses this week or next week? Guys, you have to let me know, please.
Wait, can we do it next week?
Absolutely, we can do. Maybe one more, if you don't mind, I want you to do one more on domains. Let me search for that problem. Give
Miss Priya, I have to go.
Yes, Ma, you can go. We'll finish this one problem and get off the class, guys. Give me one second. How about this? Decomposition is not what I want to do. Okay, okay. I don't know. Okay, I can keep it ready for next week, guys. I will start from there. Okay, composition of the domain of composite functions we'll do, and then we'll go to inverse function and start logarithmic functions from next week. Okay, I don't want to make you stay. Any more questions on this? But please do the homework. There will be a lot of homework. Okay, at least do the CA1, CA2 assignments. Okay, for everything, meaning 2.6, 2.7 will be there. Please do. Any questions for me? No, then we can log off, guys. See you all next week.
Thank you.
Parvini, did I help you with whatever you wanted? Composition. Yeah, okay, good.
Because like our teacher was giving like word problems on like us writing composite functions to explain the situations and stuff.
Did you understand that?
Yeah, I was
You understood?
I was struggling with that in school, but I understood that now.
Now, did you understand? Okay, good, ma. Good.
Thank you.
Bye, ma.
Bye.